Hey, this is Nick from JangaFX, and today I'm going to be showing you how to create this simple smoke plume with Unreal Engine 5, EmberGen, and possibly Illusion if it's needed. I'll be going over how to create your simulation and flipbooks inside of EmberGen, how you can set up your materials for motion vector blending in Unreal, and show you how to create the particle motion and play your flipbook back inside of Niagara. This method is probably not the most optimized or scalable way to use flipbooks, but it's simply an introductory video to get you well on your way to making great effects. So let's go ahead and get started. So to get started inside of EmberGen, we're going to go over here to a new project on the home screen. You can see that right now whenever we click new project, we have this cool little fireball that starts up, and this is currently the default inside of EmberGen. So first off, let's go ahead and clean up our node graph and remove things that we don't need. So we're going to remove things like this export. We can remove the skybox on the ground and this fire gradient because we don't need it. We can remove, say, this noise and this particle emitter, and we'll keep the noise up here. We can delete these comments. We can select all of these nodes except render and press Alt-A. That'll clean up our graph really nicely. So for the shape primitive, we're going to want a sphere. We're just going to zoom in here, Alt and middle click to kind of line ourselves up. And so now we've got this smoke that's rising. And so in the simulation node, let's go ahead and do something like 256 by 256. And even if you hit enter here, you have to click apply new resolution for it to happen. For our sphere, let's do like 5.5 meters. Let's see, for our emitter, let's make sure that we have no fuel. For smoke rate, let's do something like 495, I think. And then we need to animate our emission activity. So if I press R, we see that we have this nice little initial burst. And this is the type of effect that we want. So what we're really looking for is we want to camera track this particular burst. And so, but if we want it to be a burst, we need to go ahead and do emitter activity. So we're going to just single click this little circle. It's going to come over here and we'll do something like maybe frame 17. And on frame 17, we'll turn it off. So now we've got this cool little burst. And then from here, what we can do is let's go to our force noise. And I know that from previous tries at this, I know that my seed that I liked for the noise was seed number 846. Then let's go down to, say, our forces tab in the sim node. We're going to do 78% on our buoyancy. That's going to kind of make sure that we don't really hit the top of the bounds too much. And so then from there, let's go ahead over to our dissipation tab. We're going to make sure temperature dissipation is at 32%. Our smoke dissipation, maybe we'll do 80%, and then we'll do like 0.17 in negative smoke dissipation. So we have something that looks like this. I think this is looking pretty good. But what we will also need to do is maybe we should animate the vorticity because we don't have a whole lot of detail here at the start, but I also want about this level of detail at the end. So what we can do is in the sim node, let's go to the vorticity tab. We'll click this little circle once again. Let's just hold shift. We're going to go to like frame 160. So we can just right click, say 160. This is going to be like 12% at the end. And we'll right click here and we'll say, maybe let's do like 30%. And so now we have quite a bit of detail. And let's just kind of look up at the top of the box. We're not really hitting it. And if we are, we're probably not going to have our flipbook last that long. So I think that this is looking pretty good. But you'll notice that we have this like tail that's coming off of the floor here. So let's go to the force tab and turn off solid ground. And now I think that looks pretty great. So this right here is the flipbook that we're going to export. But the problem is that it actually goes up. And if we go to the render here, we don't want something to just, waste a bunch of flipbook space. And so what we can do is we're going to animate our camera to actually follow this particular simulation. So we're going to go to camera. I'm just going to say copy from active. And let's just kind of make sure that we center this up. So let's maybe do like 0.6. And let's make sure that we do something like this. So let's maybe do like 0.6. We'll do like negative 16. It's kind of close. Let's see here how this is looking. Okay, that's probably fine. And then let's try something like, 2.5 on Z. And so this looks pretty centered. Let's test this right here. So maybe something, yeah, I think maybe 0 is fine. Well, we are cutting off a little bit, so let's go over back to like 0.6. Okay, so now that we have this, now what we need to do is follow this as it goes up. So let's go like all the way to frame 160, and let's go ahead actually first to 0. Let's click position. We're going to just type 0.6 again so that all of this kind of sets itself up. And this is our first keyframe. Then we're going to scroll all the way to say like 160. And then we're going to do, and I know from offhand that these last camera values should be say like negative 23.4 and then 9.7. And so, but if you want to know how I actually get these values, let me just zero these out. So what we want to do is we want to go here and then we want to click these keys. Then I'm going to zoom out and then just kind of Alt and come up until this is nice and centered. And so now it looks like we have like, 0.662, negative 21, and I have like 17 here, but we want to do the 0.97 that I had, and then the 0.23. So basically what you want to do is you just want to press Z and kind of step through this and make sure that it tracks properly. And we also want to make sure that we select all of these keys and do like a linear curve instead of Bezier. And now we're just going to watch this as it goes up. And we can see that we do have a cutoff here that's happening. So let's just kind of make sure that we go here to our keyframes and let's just kind of bring that up. And let's see. Let me make sure that these are linear. Okay. And so let's just kind of step through this and watch it. It's being tracked. It's dead in the center. Something like that. I think that's pretty good. And so if we want, like say if this is getting too close to the top, we can come to this last keyframe over here. And we can do something like kind of bring that up. And so now we can watch that again, kind of see how this works. I think that's looking really, really good. This is going to stay well in the center. So that's pretty nice. So let's just make sure that these two values are the same. So we'll do like 0.6 on both of them. 0.6, 0.6, because I think that's what was causing that initial jaunt to the left. And maybe let's zero this out. Maybe it will work well in the center. Okay, so that looks really nice. Our camera movement is nice and fixed. We're tracking this fireball really, really well. Or not fireball, this smoke plume. And you'll notice that we have like these like weird little lines that happen at first. I don't necessarily think that matters because once we export this, we're going to really start kind of around this frame here. So let's go to our render node. I think we're ready to render this. So we're going to go to this. We're going to select, make sure that this is render all. We've got alpha for future reference. If you ever want to add an alpha channel, you can come here, add the alpha pass, drag that into alpha, and then make sure that you remove this link. Then we're going to go to add render pass. We also want to export a motion vector. And you can preview motion vectors here. And if you need to expand, say your blur radius, you can. So let's just do something like 5 pixels. And I think that's probably a good enough blur. Now, our motion vectors here are based truly on the velocity, not where the next frame is going to be. And so our motion vectors do have quite a lot of limitation. If you have too much motion that you're trying to skip between, our motion vectors are not going to work very well. In the future, we're going to have optical flow, and then here's really shortly inside of EmberGen, we'll have an optical flow node that you'll be able to calculate custom motion vectors for your visual effects. So in the future, use optical flow in EmberGen, but for now, this is going to work for this tutorial. We're just going to keep this at 2048 by 2048 in an 8x8 flipbook. Make sure that flipbook is selected. We're going to go down here. We're going to say it's 64 frames. We're going to do a frame stride of 2, and we're just going to kind of check this, something like that. Maybe start at like frame 35, I would think. So let's just kind of look and see where we are. Let's go back to render all. I think this is a good frame to start. And then this is going to make sure that our end frame is probably on 100 and looks like 62. I think that's probably fine. So now let me go to my project directory. I'm going to just choose my Unreal Engine textures content folder that I have. So textures, I think that's fine. And then we'll just say I'm going to not erase safe name, but I'll do like EG tutorial 1, something like that. And then go ahead and export this. So I think that we're ready. Oh, and for alpha blending, let's make sure that we select straight alpha. If you use pre-multiplied, you're going to get these weird black edges inside of Unreal, and you don't want that. So let's go ahead and export this. That looks fantastic. Let's test our flipbook here by pressing space. That looks really great to me. And so you can kind of zoom in and check it. You can click individual frames, scroll back and forth. This looks awesome. It fades really well. I like that quite a lot. Let's check our motion vector. Just make sure that it is exported, and it looks like it has. So I think we are good there. And so I will see you inside of Unreal Engine. Inside of Unreal, we want to make sure that our textures have imported correctly. So this is a smoke texture that we just exported, and my compression settings are just set to BC1, and I think that's probably pretty fine. So I'm going to minimize that, and we're going to go over to our motion vector that we imported. If we go over to compression settings, we want to make sure that this is HDR. This immediately makes the texture size absolutely gigantic, even if it wasn't this size on our disk. And so what we're going to do is we're going to go over to and type size. We're going to do a maximum texture size of 256. And so I've actually heard that you can lower your maximum texture size quite a lot with motion vectors, and it'll still have a really nice flow. And so we're lucky to be able to do this. And so you can go down to like 128, maybe 256. You can kind of type in and experiment on your own to make sure that everything is still smooth and looks good. So uncompressed, we're at 683 kilobytes. So this is pretty nice. So now let's go ahead and make the material. So to create the material, let's go ahead and right click inside of our materials folder if you have one. We're going to do material. I'm just going to say something like FXM EG smoke tutorial. I do FXM for FX material. And then first thing we want to do is we want to add in a flipbook motion vectors function. And then out of the result, we are going to multiply that into base color. And then I'm going to do a particle color node so that we can control things by particle color, just in case you want things like a red smoke or blue smoke for some kind of smoke, grenade or a flare or something like that. This is a good way to do that. And then for my alpha, I'm just going to go ahead and choose this, pull this out, and then we want to make sure that we get, say, depth fade. So let's go ahead and do a depth fade. This right here allows it so that your sprite doesn't clip into the ground too strongly. And then from our particle color alpha, we want to do a 1- because the first value is going to be 1, but we want that to act as a 0. And then we're going to use a subtract node. So here, I think we want to do something like this. And so we've got that. And so we know that our alpha is going to start at 1 inside the particle color. So we want the value to come out as 0. And then we want to subtract over time so that as alpha becomes 0, this actually becomes 1. And we're subtracting that. So just in case our flipbook doesn't end the way that we want, we'll be able to do a little bit of subtraction or thresholding to get a pretty cool result to make sure that our flipbook really dissolves nicely in the air and that you can't tell, oh, this is just a flipbook that has really bad dissolve. So this is a good way to kind of do that. And I think there's also another way that you can do a smooth threshold with a divide node, but you'd have to look up how to do that because I don't know offhand. So for our blend mode, we're going to choose translucent. Default lit is fine. We're going to plug this into opacity. And so now we've got the key part of our texture setup here. And so now let's do a object. Let's say texture, so texture object, and then I'm going to search in my folder. So let's just go here, and we're going to say EG tutorial 1, and so this right here was the flipbook that I did, and then I'm going to just copy and paste this, and then scroll up 1, and then we've got my motion vector, and we want to make sure that this sampler type is set to linear color. So if it's not set there, you probably didn't do the right compression. Make sure that this is linear color. It has to be. We want to plug this into our motion vector T2D. We want to plug this into our texture T2D on the thing here. And then we also want to add in a dynamic parameter. And so by default, you can do something like, say, time, and then frac, like this. So we'll get a fractional time animation phase. And let's just make sure that this is real time. Let's see, real time viewport. And then let's view it on like a square or something. So we can see this. And so we can kind of see this test that's happening here. And so, but what we need to do is we need to go ahead and type, say, S, and we'll do RC for rows and columns. And in this case, I'm just going to type 8 because that's what we know. And they are both 8. You would use two different parameters if they were different. So like say 8 and 4 if you had 32 frames. And so now we've kind of got this cool little thing showing, you know, what's happening, but it's highly likely that our intensity is too strong. It says that it's 1. And a lot of times with motion vectors, you're going to have something like, you know, a magic number. I do not know what the magic number for EmberGen is, but I do know that on this particular one, so we'll say in intensity, we'll do like 0.01. We're going to plug that into intensity and see what happens. And so that looks pretty nice. And now we're not really going to be able to see the blending very well, but if we did something like 0.2, you can see that this clearly has issues. And so you just want to go down and, you know, it might be like 0.02534 or something like that. That looks absolutely perfect. You just have to experiment. But with this particular one, with how slow the texture is, with how the motion vectors are kind of set up, and because there's not a whole lot of movement it has to track, I find that a value of 0.1 works very, very well. So we're going to stick with that. And now our material is set up, so let's hop into Niagara. Just kidding. We have to do the dynamic parameter. So over here with our dynamic parameter, let's say that this is going to be, let's just say phase. Unfortunately, we have 4 wasted channels here inside of our dynamic parameter. If anyone knows how to do, like, say, a particle, like whatever, like relative time or something like that, I'm not sure if the relative time node actually works. But you basically want this to be 0 to 1 over the lifetime of the particle, and I just don't know of a way to do that without a dynamic parameter right now. So that's what we're going to use, but maybe if you know, answer me in the comments and let other people know that dynamic parameter is not the way to do this. So let's hop into Niagara. To create our Niagara particle system, I'm going to go to my Niagara folder over here. We're going to choose Niagara system. I'm just going to use a minimal emitter. We're going to just say tutorial 1 or something like that. Then we're going to drag it into the world. Now we're going to view it. So we can rename this. We'll say by double clicking, smoke plume. And by default, if you've never used Niagara, it is complicated. I'm not going to lie to you. It's probably overly complicated. But down on the bottom, you have your timeline. On the left, I have no clue what the hell these are. And on the right, you have all the stuff that you're going to edit. You also have a emitter spawn here. And so these is basically a stack. And so you have your properties for the general emitter. You have your renderer that you're choosing, which in this case is sprite. It can be meshes and so on. Emitter spawn is what happens once the emitter actually spawns in the world. Emitter update is basically you want to update the emitter per frame as far as I understand. And then particle spawn is the initial birth of a particle. And then particle update is what do you want to do over the particle's life. So the first thing we want to do is we want to say, okay, for this we want to do a spawn rate. We're going to do a spawn rate of 2. And we're going to leave that as is. And then the next thing we want to do is initialize our particle. And I'm going to set our lifetime to be something like, so I'm going to set our lifetime if the thing doesn't crash. We're going to set our lifetime to be a random range float. I'm going to do maybe like 5 and 7, I believe is probably pretty good. And then I'm going to go ahead and add in some velocity. So let's just do an add velocity. You'll see that it says you need to add a module called solve forces and apply initial forces. And so we're going to go ahead and do a solve for forces is my choice. Now you can see that we have some particles that are moving, and that's pretty cool. So inside of add velocity, I'm going to do something like maybe 50. Let's do kind of a range. So we'll do a random range, maybe vector. And so we'll do, say, let's do like 20, or actually let's do like -20, -20, 50, 20, 20, 100. Okay, so now we've kind of got these particles that are kind of, acting a little bit differently. And that's everything that we want to do for particle spawn. And so now let's go over to our sprite renderer and actually see some cool stuff here. So we're going to go ahead and we're going to say, let's see, FXM, I believe it was called like tutorial, e.g. smoke tutorial. Yes. And here we go. And now you can see that we have these little sprites, but they are not animated. So if we want to animate them, which I think we should probably go ahead and do that, is under particle update, let's do a dynamic material parameter. And then for phase, which is basically the animation phase, we just want to do a 0 to 1. So we're going to do float from curve. We're going to call this right here 0. And then we're going to select this triangle that's at 1, and we're going to say 1. This is just going to be a linear curve, no special animation or anything like that. And you can see that this is actually kind of animating. So for initial particle size mode, we're going to say random uniform. And let's do something like, I don't know, maybe 50 and 70 or something like that. So something, rather large. And then what we can do is we're going to go and choose, say, particle update. And then we're going to do, say, scale size. And then we're going to choose scale sprite size. And then I'm going to set this to auto. And I'm just going to make this go up. Then I'm going to select this triangle. And I'm going to do something maybe like 6. And then what we can do is hit this little button to kind of see everything that we just did. I'm going to move this auto a little bit. And so now we have these growing pieces. And maybe for my scale here, let's see, for this particular one, maybe I'll choose like maybe like 0.5, maybe 1 as my initial size for the first key. And so maybe we'll even do something like 2. And then let's kind of tweak this so that it's not kind of shrinking at the end. We don't want something like that to happen. And so now, I'm thinking this looks pretty good. And one thing that I want to mention is that we can kind of see that something's happening here with our dynamic parameter. So maybe here, maybe we want to do like 0.98 for our final key range. See if that fixes it. As far as I know, it should. And so I don't know why that happens. I have had it happen to me in the past. So we're just going to choose 0.98, and I think that's probably it. Maybe it's trying to blend into something that doesn't exist, or maybe it's trying to reblend into the first frame or something like that. So we don't want that to happen. And so the next thing we want to do is let's go ahead and add some wind. So we're just going to come here. We're going to type wind force. You can see that it has an issue, and so it's going to say that it has dependencies, and we'll see that it needs a drag. So we'll go ahead and add a drag node, and then this right here says it cannot be after solve forces and velocity, so we'll just drag the forces and velocity down. And so now we kind of have something cool happening here. We've got this particle system. It's kind of nicely moving over to the side. So for the wind force, let's do something like 100 and maybe 50, because I really want it, 50 in the z-axis. I really want it to kind of go upwards quite a bit. And so I think that this is looking pretty nice. Let's kind of drag off and see how this is looking in the real world. And so far, I think that this is looking pretty cool. The forces look like they're doing pretty well. One thing that we need to do is you'll notice that every single sprite is facing the exact same direction, and that is not cool. So what we're going to do is under initial particle, let's do, I think it's sprite UV mode. It is. We're going to choose random X, and so that's going to flip each kind of particle just randomly on different axes. And that's going to make sure that we don't have as much repetition inside of our smoke. And so that's really quite cool. And then for particle update, so you can see that like this does fade out, pretty well. We can look here, it does fade out pretty well, but like it's really, really clearly like a simulation type fade out, or just like this weird hard decay that kind of comes from EmberGen. So we're going to use our material trick that we did. And so what we're going to do is we're going to come back over here to Niagara, and then we're going to say particle update, and we're going to do a scale color. And so what this is going to allow is for us to scale, say, just our alpha over time. I'm going to do a float from curve, And then we're going to make sure that at the beginning our alpha is 1. Let's go ahead and set this to auto. And we're going to do something, let's set this to auto as well. So something like this. And so I think that's going to be pretty cool. And then as it fades out, it's going to have a much better and quicker erosion. It's also, so not only is it, just the alpha color itself that's being lowered, but it's also doing that simple like threshold erosion as well. And so I think this is looking really, really quite great. I don't think that we need any other nodes. I think that's pretty much it. We could just kind of, change, say, maybe our initial particle size or something like that. So maybe let's do like, say, 60, and then maybe we'll do like a maximum of 8, I would think. And then, I think we also need like a bit of a initial like rotation mode. So let's do, say, direct angle. Let's actually do random. But then we'll do a random range float. So how do I do that? Let's see. Dun, 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 dun. Okay, random range float. So under direct angle, we'll do random range float. Random range float. Here we go. Let's do like -30 and 30. So I'm just kind of going through and checking my stuff here. And then maybe for like add velocity, maybe we want to do like a random range as well on this. So we'll do, say, random range float. And let's do, say, like just 1 and 2. And so we're going to get these, various bursts of different sizes, as if there's like heat waves that are kind of coming up, and, some things are flying a bit higher, some things not so much. And so I think this is really, really quite nice. And then maybe let's look at our scale sprite size. And so on my other screen, I'm just going to look at my sprite size here, see if there's anything I'm missing. I don't necessarily think that there is. It looks like I did 7 for my final size here. So we can just do, say, 7. And I think this is pretty much it. You can go through, you can tweak things like, say, your drag, you can tweak your wind force, you can tweak, your scale over life. You don't really want to tweak the dynamic parameter, but if we look at this and we can compare the two, you can see this right here is my first one. This is the one that we just created. You'll notice that this one right here is a bit brighter. So if you want that, you can actually go to, say, scale color. And so where is it at? Let's go to my scale color here. We can just do something maybe like 333. And now we have kind of a brighter smoke. And so that's pretty cool. They're almost identical. And so I think we did a pretty good job with this. If anybody also knows, I do not know why this will not cast shadows. I'm kind of stumped on it. It should cast shadows, but it does not for whatever reason. So if you know how to fix that, go ahead and comment that down below as well. And there's a few other issues that this has that I don't know enough about Niagara yet, but basically there's a sorting issue if we kind of come over here. And then if you look too close, you can kind of see that this is a bit jittery. That's because we're using a velocity-based motion vector instead of optical flow. But I will do a tutorial on optical flow once we add that in to Illusion. So hopefully this helps you kind of understand the workflow to get sprite sheets inside of Unreal. This kind of goes over the Niagara stuff and how to make some smoke plumes. And this also works for things like explosions and fire and so on. It's just adding stuff to a sprite. Now, one last thing I will mention is if you wanted to, so let me actually go over here. Let's choose, say, something like this, ground fire. Maybe actually, let me choose, let's say, Niagara System 1, maybe? Okay, so we've got this little anomaly effect that I made. And let me just isolate some of this fire here. Maybe something like this, we'll isolate it. And so you can see that I've got this fire that's here on the ground. Now, a lot of the times, you're probably not going to use something like motion vectors. It is mildly expensive to do. And if you're not, going to be extending the life of a particle, you're probably not going to want to use it. You just want to use simple SubUV animation. And that's going to make sure that your texture just looks like a grid inside of the material. And so what you want to do is over here, you want to go into your, say, sprite renderer. You want to go to SubUV, type in the sub image size, make sure blending is enabled. You want to use your material cutout, and then you want to go to SubUV animation. Make sure that you choose your sprite renderer. And then that's pretty much it. And you want to make sure that it's based on normalized age, and that's going to make sure that you can play your sprite UV. And so I had initially, when I was learning Niagara, had a bunch of issues with this. It's because I did not select sprite render. For whatever reason, it does not auto select, but you have to select it. And so hopefully that helps you out. And if this tutorial was helpful, go ahead and comment below and let me know. Like and subscribe, and we'll catch you later.